welcome to Algebra Online. Today we're going to be looking at exponential equations in tables, and we're going to start to make some connections. Before we get started, let's go ahead with our opener problem, and we are going to solve the equation for n. So the first thing that I would like you to do is to recognize that we can distribute the 4, and we can also distribute the 3. Now within this equation, we do have the equal sign that's in the center of both of those. So we're going to go ahead and multiply 4 times n is 4n, and 4 times negative 6 is negative 24. And then on the right side of the equation, we have 3 times 2n, which is 6n, and then 3 times negative 2 is going to give us negative 6. Now, if you notice, we have variables on both sides of the equation. We have the n on the left side, the 4n on the left side, and the 6n on the right side. So our goal is to get the n by itself, so we need to move the n to the other side. Now, you could add the 24 to the other side. You could add the 6 to the other side. What I like to do is I like to move the smallest variable first, and that's just my strategy. And so that's what I'm going to do. I'm going to subtract 4n and subtract 4n. I'm kind of running out of room, so I'm going to write off to the right-hand side that on the left side of the equation, I now have negative 24 equals, and 6n minus 4n is going to give me 2n, and it's going to be subtract 6. So from there, my whole goal is to get that n by itself, so I'm going to go ahead and add the 6 to the other side. Negative 24 plus 6 is going to give me a negative 18 equals 2n, and n is being multiplied by 2, so the opposite or the inverse is to divide by 2, and negative 18 divided by 2 gives us n is negative 9. Okay, so now let's go ahead and get into some exponential functions. If you notice on the right-hand side, we have a table, and that table is looking at the bounce number and the height. And the first question is asking, what is the rebound ratio? So what's happening is that we have some sort of a ball here, and it's being dropped, and it's gonna bounce. And as it's bouncing, it's gonna keep getting smaller. As you notice, the numbers for the height, they are getting smaller. So we would like to find what that rebound ratio is. And to do so, we're just gonna go ahead and take a look at the change, what is happening each time. Because this is exponential, we're looking for a multiplier, and it's getting smaller, so we know that the multiplier is going to be less than 1. So I'm going to divide the 67.6 divided by 84.5, and I'm going to get about 0.8. And that is going to be the same each time. So our multiplier is going to be 0.8, and that is the rebound ratio, 0.8. You would find that you would also get 0.8, about 0.8, if you were to also check all the numbers at 54.1 divided by 67.6. All right, so the next question is asking us, at what height did the ball drop? Well, that means I would like to know the very top of the height where the first bounce number would be 0, because the ball didn't bounce at all. So to be able to get that, let's go ahead and go backwards on our table. And each time, instead of multiplying by 0.8, let's go backwards and divide by 0.8. So when you divide by 0.8, and what do I mean by that, is you would do the 84.5 divided by 0.8. Instead of multiplying each time, we're going to go backwards. And when we do that, the one height, right, is about 105.6. Always double check your math though, right? Is 105.6 times 0.8 the 84.5? And indeed it is. So we need to do that one more time. So then we need to do the 105.6 divided by 0.8. And when we do that, we get about 132. So when we do this, this answer is here, and then we just kind of keep going back. All right, so what is the equation? Well, since this is an exponential function, we know that the equation is y equals a times b to the x, where a is our initial value. Our initial value is the height where the ball initially dropped, which is 132. So I'm going to write y equals 132. B is our multiplier, 0.8, and it is to the x power. All right, let's go ahead and take a look at another example. For this particular example, let's look at the table first. What's happening? Well, it looks like as the days are going by, uninfected computers, okay, maybe they didn't have a virus, is going down. All right, so now we would like to see how many unaffected computers are there in day 3. First, we need to find the multiplier. What is this, all these unaffected computers going down by? Well, what I would do is I would recognize that number is going down. And because it's going to be an exponential function, I would like to divide. So I am going to do 18 divided by 27. And when you do 18 divided by 27, you're going to get about 0.6 repeating. Now 0.6 repeating exactly is 2/3. So if you do that one more time, 12 divided by 18, that is also 0.6 repeating, or 2/3. You can just simply simplify the 12 over 18 to get 2/3. And so therefore, I'm not going to use the decimal this time because it is a repeating decimal. I would like to use the 2/3 as the multiplier. So basically we're taking the 12 over 18 and dividing by 6. So 12 divided by 6 is 2 and 18 divided by 6 is 3. And since that's our multiplier, right, each time it is multiplying by 2/3, because that's the exact number and I don't want the rounded number in my equation. To write the equation, we have y equals the initial amount. Now the initial amount is 27. So 27 times our multiplier, and I'm going to write 2/3. I just recommend whenever you have a decimal that you are rounding, you have to round that 0.6 repeating, it's just always good to use the exact number, in this case 2/3, and it is to the x power. All right, so we actually only have this last example for today. And if you take a look at the table, it's blank. So let's go ahead and take a look at the equation. They give it to us first. Can we go from the equation to the table? Yes, we can. So what I'd like you to do for our x values, let's start off with 0, 1, 2, and 3. And we know our initial value is 20. Right? If you were to plug in 0, right, for x, if you were to plug in 0, 3 to the 0 power is 1, and 1 times 20 is 20. Now there's a couple of different ways that you can fill out this table. You can recognize that the multiplier is 3, so you can just simply multiply by 3 each time. Or you can take the value of x and plug it in and compute that value. So if you were to do that, and let's just say we're going to use the multiplier and we're going to multiply by 3 each time, then we would have 60, and 60 times 3 is 180, and 180 times 3 is 540. All right, guys, I hope you enjoyed today's lesson, and I will see you next time. Bye.